Okay. So yesterday we just reviewed from Algebra 1 that we know how to already solve two variable systems. And since we're in Algebra 2, we're going to up the ante here and add a third variable. So generally that third variable, instead of having x and y, it's going to be an x, y, z. We're going to have three variables we need to find. This possible solutions for your three variable systems, this shows up on page 30. So if you want to look at these pictures again on your own, you can. Again, I think I mentioned this yesterday, but SOL''N, that's just my abbreviation for the word solution because I'm too lazy to write it out. So however you want to abbreviate or write out solution is up to you. Okay. In three variables, so like if you have an equation with two variables, x and y, that comes out looking like a line, a linear function. If we add a third variable, we're adding a third dimension, so now we have to think 3D, okay? And if we have an x, y, z equation, then we're coming up with planes. So remember from geometry, a plane is a flat surface, continues on into infinity, but we can imagine it like a piece of paper, right? So it is possible for three planes to intersect at a single point. Okay. So imagine these three pieces of paper. Okay. There's a single point where all three planes will intersect each other. There are many points where like two planes are intersecting. So like the blue and the pink intersect all along this line. The green and the blue intersect like left and right there. And the red and the green are also intersecting on like a vertical line. Okay. But the only place where all three of them intersect each other is right there in the middle. And so that's most like the one that Tommy and Morgan did, number 5, where your one point is an X, Y, Z ordered triple. And just like X, Y ordered pairs, if it's X, Y, and Z, you should put it in alphabetical order. So your X should always go first, your Y would be second, and your Z would be last. Now, that would be an example of a consistent system where there's at least one solution. You can also have consistent solutions where there are consistent systems where there are infinitely many solutions in 3D space. Here's an example. If we have three planes that intersect at infinitely many points, notice all three, the red, blue, green, they're all intersecting at that vertical line. So all the points on the line are solutions to the system. They would make all equations true. And we can't count all the points on the line, so we would say infinitely many. Another type of system that you might encounter would be the inconsistent system. And an inconsistent system is going to be a system that has no solution. So these are kind of modeling for you ways that three planes could never intersect. You might see some intersections, like on this first one with the triangle. The blue and the green do intersect each other at a line. The red and the blue intersect at a line, and the green and the red intersect at a line. But never do all three touch at the same place. So there could be intersections for two of them, but there's not an intersection for all three. Okay. Also, you can have parallel planes, right? They're never going to intersect. And you could have two parallel planes and a plane that intersects those parallel planes, but then all three are never going to cross. So there's lots of ways to have inconsistent or no solutions. For the no solution and for the infinitely many solutions, it works the same way that it did in two variables. So if it's no solution, what's going to happen is you're going to get a false statement, like all your variables all of a sudden disappeared, all your x's, all your y's, all your z's are gone, and you come up with something like 0 equals 5. 0 is not equal to 5, therefore there is no solution. Okay, Okay, so you would know when you would come up with one of these pictures, okay, because you would get a false statement. If you were to answer infinitely many solutions, that would be a true statement. So generally, it's something like 0 equals 0, and then you have infinitely many solutions. So those are the same as 2 variables and 3 variables. All your x, y's, and z's just disappear. And you have infinitely many. It doesn't always, I will say this, especially because I know some people in 2 variables are using substitution a lot. It doesn't always equal the equation 0 equals 0. It could be something true like 5 equals 5 or negative 3 equals negative 3. That's also infinitely many solutions. And that happens more often with substitution. In elimination, it's usually 0 equals 0. Okay. So that's basically what can happen in 3D. Let's do a 3 variable example. I'm only going to do one with you, and then we can give you time to work. So make sure that you copy this down, you write down information that you're going to need to look back on. I'm going to write a little bit more than I would always show in my notes, or in my homework, only because it's my notes. So I want it to be like when I leave AO8 and I go home tonight, I won't be able to open up my notebook and have it make sense to me. Don't you hate that when everything is clear as day with Miss Cronky and then you're on your own and nothing makes sense anymore? Isn't that weird? How that is? Okay, so I'll read out these equations if you want to write them down as I'm reading them, or you can look at the board and write them down, but of course you got to write them down correctly. That's really important. First equation, 4x plus 2y plus 3z equals 12. Second equation, 2x minus 3y plus 5z equals negative 7. And third equation, 6x minus y plus 4z equals negative 3. Now, I really do want to help you guys when you get into a tough spot and you've made a mistake. I want to help you find your mistake. In 3 variable systems, it's usually something so small as a negative. It's something like you did 2 times 3 and you wrote 5. Or you added incorrectly. It's something really, really small. But if you don't subscribe to my organizational system and you do some work everywhere and never label it, I really can never find your mistakes. All I know is it's wrong, really wrong. Okay. So here's how we can all organize and help each other and help ourselves. First of all, just like when Morgan and Tommy were talking about the equations on number 5, label them. I label them 1, 2, 3. You could use any labeling system that you would like to subscribe to. And when you decide to use, we're going to use 2 at a time. When you decide to use 2 equations, label which equations you're using, 1 and 2, 2 and 3, 1 and 3, whatever that may be. And if you're going to apply anything to them, like you're going to multiply it by 2 or you're going to multiply it by a negative, write that down. And then we know how we got our answers. Okay, so I'm going to backtrack and, if we add up all these, the x's, y's, and z's are probably not going to cancel so nicely. So we're going to work with 2 equations at a time. We have to make a decision at the beginning to eliminate one of the variables. So we're going to take it from a 3 variable system to a 2 variable system. Do you want to eliminate x, y, or z? Take a moment to look over your 3 variable system. I would argue that in some cases it's possible to work smarter, not harder, if you look at your coefficients. Anybody want to make an argument for what they want to eliminate? Austin is saying x, y?
Because 2 times 2 is 4. So.
2 times 2 is 4? That's your only reason?
That's for x.
Oh,
So you can
okay.
just multiply.
Anybody else like X or Y or Z for a different reason? I don't mind X on this one, but I would argue this. Yeah, 2 times 2 is 4, but I'd also look at that third equation. Oh, 2 times 3 is 6. So that would be nice, too. Because you're going to have to eliminate X 2 times. So you're going to have to use different pairs. I probably wouldn't have chosen X if one of those coefficients had an odd number on them. Because that's not as easy to turn 2 into an odd number. Okay. Does anybody think any of the other variables might be nice to work with, knowing that you have to use all 3 equations? I probably wouldn't choose Z's because 3, 4, and 5 don't share any common factors. So that's like, I like X's better than I like Z's. Why do I like Y's best of all? There's some that are negative, there's some that are positive. What else is really wonderful about one of those Y's?
Just Y.
Its coefficient is 1 or negative 1. It's just a Y. That's a really easy one to get like for elimination because you just multiply it by the number that you want, right? So I'm actually going to recommend, you could have chosen X's. You guys aren't wrong. But if I'm going to like push you on thinking smarter, not harder, I'm going to say I would choose Y's in this case. So let's eliminate Y. I'm going to write this down so my notes make sense later. Eliminate Y twice. So this means I'll do it once with 2 equations, then I'll pick another 2 equations and I'll do it again. By eliminating Y twice, I will have created 2 new equations in X and Z's only. So, which equations do you want to use to eliminate Y's? 3 and 2. Okay, right now I have a coefficient of -3 and a coefficient of -1. In order for them to eliminate, they need to be opposites. So I probably want to leave 2 alone, but I want to multiply 3 by -3. You see how I'm writing that down so everybody knows what I did? You should be doing that on your homework. If you don't do that, I cannot help you find your tiny mistake. And it's going to be real frustrating because you're never going to get the right answers if you're missing negatives or small things. So please write that down. Okay, let's do it. -18x plus 3y minus 12z equals 9. Right? I just multiplied every single term in equation 3 by -3. Okay. And I'm going to leave equation 2 as is. So 2x minus 3y plus 5z equals -7. Okay, I don't want to go too slow, but I also don't want to go too fast, so I'm just going to ask this question. Are we okay with why we did what we did? Anybody got any questions they're dying to ask? We want to hear them.
So did we multiply 3 by -3 to get the y to go into
Yes. We said we were going to eliminate y's, so we had to get opposite coefficients because we're going to stack and add these. So they'll only cancel if they're opposites. Okay, add down. Get -16x minus 7z equals 2. And that's a brand new equation, but now it has only 2 variables, not 3. I'm going to call that equation 4. Now remember yesterday when we were trying to save Trent from that evil king, we had 2 unknowns, nickels and dimes, or sorry, nickels and quarters. And if you have 2 unknowns, you can't solve an equation. You have to have 2 equations. So that's why we've eliminated y once. Now we're going to eliminate y
Twice.
again. So probably want to use equation 3 and 1. Multiply 3 by 2. So that we'll get a negative 2y and a positive 2y. So I'm going to do 1 and 3 times 2. Copy 1. 4x plus 2y plus 3z equals 12. Multiply 3 by 2, so that's 12x minus 2y plus 8z equals negative 6. A lot of times people forget to multiply that very last number by 2. They'll write negative 3. Got to multiply it by the whole thing. The y's are already opposite. This is plus 2y, and this is negative y. So we just need to multiply by a positive 2. We'll have opposites. Okay, you should be canceling this same variable. Don't cancel x, then cancel y. That's not helpful. You gotta cancel the same variable 2 times. So we come up with 16x plus 11z equals 6. Did I do my math correctly? Okay. So, with the equation 4 and 5, you see 4 is in terms of x and z, and 5 is in terms of x and z. So, we've created a new 2-variable system, which you already know how to solve, right? 2-variable systems. So, I'm going to write in my notes, solve the 2-variable system with the equations 4 and 5. Okay. Now, this example that I have on the board works out pretty nicely because what happens right away?
X cancels.
X will cancel, so we don't have to multiply 4 or 5 by anything. Sometimes at this point you might still have to say like multiply equation 4 by negative 2, multiply equation 5 by negative 1, whatever that may be. Okay, so we're just going to stack and add 4 and 5. Some of you are probably on the road to finding all your variables, which is fine. Bless you. The x's cancel. I get 4z equals 8, therefore z equals 2. Just like Algebra 1, plug that into either one of the equations, 4 or 5. I'm going to plug it into, I'll do 5. So I'm going to say 16x plus 11 times 2 equals 6. And that's 16x plus 22 equals 6. Subtract 22, that's 16x equals negative 16. So x equals negative 1. I'm going kind of fast in my math there because I assume you already could solve the 2-variable system. Does anybody have any questions for me as I'm doing that? Could I have plugged 2 into equation 4? Sure, I will come up with the same answer if it's truly a system, if I had solved it correctly in the first place. Okay, now that I have x and z, what should I do?
Plug both variables into another equation.
Plug known variables or values into 1, 2, or 3. Does it matter which original equation I use? No, as long as it has y in it, I should be able to solve. So I'm going to use the bottom one. 6x minus y plus 4z equals negative 3. 6x minus y plus 4z equals, was it 3 or negative 3?
Negative 3.
Negative So that's -6 plus 8, which is 2 minus y equals -3. So I'm getting negative y equals -5 or y equals 5.
Yeah.
Okay. Now, when you write your answer, remember how we used to write our answers as ordered pairs? Now it's going to be an ordered triple, and it has to go in
XYZ.
alphabetical order, X, Y, Z. So we're going to say -1, 5, 2. Did I get those right? Okay. If I take -1, 5, or 2, and I plug it into any other equation of the original equations, it should be true. So if I go back up here, that would be -4 plus 10. What was our z value again? 2 plus 6. So that's 16 minus 4, which is 12. That works out. Or plug into 2, it should also work out. I forgot all the numbers already, so I'm not going to plug it in. My screen is not large enough. Okay, any questions, concerns you want to ask me about?
When you do like a variable system
Yes.
and you get a
Intersection point?
how why would there be lines? Just like lines.
Well, because in the system, so I'm not going to do a 3 variable because I can't really draw in 3D. But in a system, if I have like 2x plus 3y equals 6, that has an x and a y. That's a line. This is really 3y equals -2x plus 6 divided by 3. That's y equals -2/3 x plus 2. So I'm graphing a line with a y-intercept of 2, and it has sloped down 2 over 3. And then if I have another equation, that's also a line, a linear function, and they're intersecting at a point unless they're parallel. Okay, or the same line. Good. Anything else that you want to ask about? Yeah, Emma.
So like at the beginning, you don't have like one that's like 1 or -1, you just randomly choose.
Yes. So let's say I didn't have the -1y. Let's say this was -5y. Then I wouldn't have chosen x, or I wouldn't have chosen z, because 3, 4, and 5 don't have anything in common. I probably wouldn't have chosen y, because 2, 3, and 5 don't have any in common. But there might always be, like, there isn't always a think smarter, not harder part. But remember, x wasn't a bad choice. These are all even, so like we could have used equation 1 and 2, multiplied 2 by -2, and the x's would have canceled. Then we could have used 2 and 3, multiplied equation 2 by -3, and the x's would have canceled. So then I would use this because all the coefficients like have something in common. So yeah, if there wasn't one that was 1 or -1, I would still look around for like, oh, those are all even numbers, or those are easy to get to be 12, or something like that. Does that make sense? Anything else? Okay, you have the rest of the time to work on the homework assignments. Okay, the homework assignment for today is page 34, numbers 1 through 5. 1 and 2 are fast. You're going to be done with them in about a minute. And then 3, 4, and 5 are 3 variable systems that you have to solve. So you have to solve 3 of them today. Okay. I will say in advance, this is not always true, but on today's homework it is. All of your x, y's, and z's will be integers, which are nice numbers, right? If you get any fractions or decimals, you have an error. So that's a nice way for you to self-check as you work. 9 and 10, you don't have to solve the whole system. It's just identifying an error, okay, which is good for us to do. This one, my favorite memes. Oh, Willy Wonka. Because I like to give you homework, and you like to complain. Okay, get your books out. You have over 10 minutes. You should be able to get at least through number 3.